How do you maximize nutrition in the things that you grow? It's not really all that hard. First, you've got to think about your objective. My objective is year-long production of real food. I know it's safer. You don't have the issues with listeria and some of those diseases because you go pick it. Doesn't have time to spoil. The salvatrols are all there. They're not there except for 3 to 4 days prior to that fruit being dead ripe. So if you get commercial stuff that's outside of that window, do you get the salvatrols? No. It's profitable both from cost and time. Now, I'm not an exercise gym guy, okay? But I know I've got to have exercise, and the best way to do it is out there with that O.negative oxygen outside. You get sunlight, you get air, you get exercise, all at the same time. You'll get higher nutrient density, and you can really get toward being self-sufficient pretty easily. But the compelling reason to produce real food is our health. And I would suggest that each of us need to do it for that reason. What is organic? Organic is whatever the country it's grown in says it is. Well, that may be a surprise to you, but it may not be defined the way the country you live in defines it. It may be grown somewhere else, and they may grow it differently than we do. Wherever it is, naturally grown is grown without chemicals or pesticides. And it may be grown naturally. But what's in the soil? What's in the air? What's in the water? And we need to talk about deep versus shallow organics, and we're going to do that because most organic food is produced using organic inputs. It's not a deep organic with the biology and all the things present. It's just a skimming across the top like commercial agriculture unfortunately is many times. But real food is way beyond organic. Nutrient-dense production is a program that optimizes DNA potential to maximize nutrient density in food. How do we do this? Well, we get real food by maximum biological vitality, allowing it to reach its full DNA potential for maximum nutrition, maximum production, and a healthy immune system for disease and insect resistance. We've got to be careful of our inputs. We don't want, even when we mineralize, we need to be careful of the contamination in our minerals, because you can get raw minerals that are mined and powdered that will have heavy metal contamination. So you need to be knowledgeable about what you're doing. In sewage, there are all sorts of things. In water, there are birth control. There are medications, antibiotics, besides heavy metals. And everything you include in your growing area, you need to think carefully about. What's in your manure? Well, it may not be just the weed seeds from that farmer who gave you the manure, because I had a friend that was starting up a greenhouse, and he says, "Hey, I want to use spent mushroom compost." And I said, "Well, What are you going to do with the used syringes that you're going to find in the mushroom compost? What? I said, well, I've bought several truckloads of it, and I would find anywhere from 5 to 15 syringes in it. Well, where'd they come from? Well, they go to the horse barns and clean out the horse barns, and the syringes are in the horse manure in the horse barns. And they go grow mushrooms in them, and they've still got, well, I don't want that. Okay, that's why I brought it up. Just be very careful as you consider your inputs that they're clean. We want to watch whatever process we are using. There are many processes, but I would suggest there's one best one. And that's the one that nature has, that nature has always used, and potentially optimizing nature, making sure that nature has everything at its disposal to optimally function. That's what I'm after. Biological agriculture is a new and coming term in agriculture, and there are good results coming from it. Justus von Liebig, who is known as the father of fertilizer, developed what is known as the law of the minimum. It's quite simple. Basically, what he said is that unless the soil is in the perfect balance, the yield or quality potential of a crop is like a barrel with staves of unequal length. The crop will be limited by the shortest stave in the barrel. And in our area, the one that I'm familiar with is boron is always going to be lowest, followed very quickly by copper. So you can probably just know that because you live in this given area, you're going to be low on boron, low on copper. You're going to probably have plenty of iron, plenty of manganese by living in this area, but you're never going to know unless you test. And I have friends that grow organically for a living who have yet to test their soil. I don't know about you, but I would call that a travesty of knowledge. Because how are you going to get the best if you don't even know what you have? As minerals go down, the diseases go up. And between 1980 and 2011, heart conditions increased 412%, chronic bronchitis increased 819%, asthma 4,138%, tinnitus 203%, bone deformities 347%, with associated mineral deficiencies. It happened when farming became mechanized, increased tillage, and then about 1948, ammonium nitrate began to be used as a fertilizer to stimulate plant growth. And then in 1960, the pesticides, herbicides, and fungicides came into widespread use, started. And then in the mid-1990s, 96 I believe, we began to get genetically modified crops that were modified so that chemicals could be sprayed over the top of them to kill the weeds. And we were told that they weren't going to bother the crops. I'm sorry to tell you that that hasn't proven out in the facts. 1950, an apple had 4.3 milligrams of iron. In 1998, that same apple had 0.18 milligrams of iron. And so you can see that it's going to take 26 apples to give you the same iron. We know that through NPK, nitrogen, potassium, phosphorus farming, the trace minerals have been leached out of the soil. They haven't been replaced, just those three main ones have been added. The USDA, U.S. Department of Agriculture, estimates that during the last 50 years, soil minerals have been depleted between 16 and 79%, depending on the mineral. There was a man in Kentucky years ago that decided there must be a principle involved here. And so he began mineralizing his soil, and he went to the supermarket and he bought spinach because he was growing spinach. And he found out that on average, he bought 2 sets of spinach. On average, they tested 1,100 parts per billion for iodine. And he tested his own spinach, and it tested 640,000 parts per billion for iodine. And he was convinced because that was a 58,200% increase in iodine. Now the question is, do you want to eat one leaf of spinach, or do you want to eat, well, let's see, it would be 582 leaves of spinach to get the same amount of iodine? Well, again, iron increased 4 times. Other minerals increased up to 1,000 times. So the question is ours. What do we want? Do we want nutrient-dense produce? And if so, how do we get it? There are 17 essential plant nutrients, and there are 15 additional elements required for human health. Then we have trace minerals that support as catalysts the various enzymatic processes that happen in our body, and we need to supply plenty of trace minerals. So I use 2 and bicycle them down through time. I use C90 and granite fines, azomite, green sand, and I use humates to make sure they're broken out into the water-soluble solution. The body uses various minerals. It's interesting to note that the body's use is different than many times we take as supplements. Many times those supplements will not be used by the body because they're the wrong type. But if it comes from a plant, our body can break that down and assimilate it. We use aluminum, arsenic. Well, that doesn't sound very good. Oh my. Bromine, cadmium, chromium, fluorine, germanium, iodine, rubidium, selenium, silicone, sodium, tin, tungsten, and vanadium. All sorts of things in minute quantities. So how do you figure it out? Here's a copy of a soil test. You don't want just any soil test. You want a good soil test that gives you the calculated cation exchange capacity. You want the cation saturation that gives you the percentage of potassium, calcium, magnesium, and hydrogen that's involved. And then you have all these other minerals over here that you do something with. Bob Gregory is a friend of mine who worked for the world's second largest rose grower. They grew 2,400 acres of roses a year and grossed about $40,000 an acre. They had plenty of money with which to do research. Being the good agronomist that he is, he was wondering how much of each one of those minerals is the optimal amount. How much nitrogen, calcium, potassium? Well, the answer to that is you do replicated field trials. And what you do is you have everything the same except for one thing. And then you graduate, you have too much, and then you run it down through the optimal level to too little. And you establish what the optimum is for that mineral. And then you go to the next one and the next one and the next one. And what he gave us was that you need 8,000 pounds per acre of calcium. You need 720 pounds per acre of magnesium, 880 of potassium, 160 of phosphorus, 80 of sulfur, 40 of zinc, manganese 80, iron 80, copper 8, boron 8. You need estimated nitrogen reserves of 160, and this is just to get you started before you get into the trace elements. But if you get this right, anything you grow will do well. You don't have to worry about your pH. You just get everything balanced and you move right along. But you don't use just any mineral, because in the Western Fertilizer Handbook, you'll find out that in the production of certain agricultural minerals are certain chemical processes that give you junk, various chemicals, various other things that you don't want. So we use what are known as generally recognized as safe minerals. And there's a whole list: phosphorus, monoammonium phosphate, and triple superphosphate. Magnesium, magnesium sulfate or Epsom salts. Sulfur, elemental sulfur. Manganese, manganese sulfate. Copper, copper sulfate. Potassium, potassium sulfate or potassium nitrate. Calcium for gypsum. Zinc sulfate for zinc. Iron sulfate. Borax for boron. Molybdenum for sodium molybdenate. Nitrogen, urea, ammonium nitrate or calcium nitrate. And because of the methods of manufacture, we use specific compounds. Well, we use trace minerals. We use humates. I use granite fines because that's a trace mineral source that's cheap, $30 a ton. And then I use biology, mycorrhizal rhizomes and archaea, and I tend to till very sparingly. So what are the advantages? It tastes better. You have more minerals. All the protein is better. The sugar is better. In fact, one grandpa decided he was going to test his grandkids, and he did the testing. I'm getting ahead of myself, but I'll tell you the story anyway. He tested the bricks. I'm going to explain that in a minute. That's the mineral content, which somewhat equates to the sugar content. And then he cut the cantaloupe up and he offered them to the grandkids. And then he suggested that they could take this one and this one home with them. Oh no, Poppy, we don't want that. We want that one. And it just so happened that that one had a high bricks level and it was nutrient dense and had high minerals. But I'm getting ahead of myself. If we do mineralize, we'll have a 20-year fertility reservoir that we can retest and tweak every 3 to 5 years. But we will have the advantages in our produce. I know of Pink Lady tomatoes that have sat on the counter unrefrigerated for 9 months. I know because I have a cabbage in my refrigerator that is from last summer. I have sweet potatoes in the basement that are 2 years old. I know of what I'm speaking. What you do is you get a bricks refractometer, and the true bricks measures a combination of sugar, amino acids, oils, proteins, flavonoids, minerals, and other goodies. It's not just one thing, so it's not real specific, but an increase in bricks is an increase in carbohydrates and mineral density, while a decrease means decreased. That's what it looks like right there. We used to use one to do specific gravities in the hospital laboratory for urinalysis. The specific gravity is how dense that liquid is. Now this is recalibrated. That you do jams and jellies with some of them, but this is a bricks refractometer, and you take a little bit of plant sap or juice, you open the clear plastic window, and you drop your plant sap or juice right down onto your refractometer. And you close the window, and then you look up at a light source, and you can read the bricks in it very clearly. Well, I say very clearly, the best readings are those that are faint, because they have so many other things that reading declination is not real clear. It's a little bit fuzzy, and that's your highest nutrient density. I would suggest to you that this is a coming thing. I do not read French, but I can figure out that on this box of grapes, de sucre is of sugar, garante has to be a guarantee, of 18 degrees bricks. They are selling grapes guaranteed to be at least 18 degrees bricks on the brick scale. That's how they're selling them. So I think it's something to come. I think we will at a point in time be able to point something at produce and be able to measure it. I understand they're developing that right now. Okay, so I'm a grower and I'm growing stuff. How good is my stuff? Well, here's the table. There's a refractive index of crop juices calibrated in degrees sucrose or bricks. Asparagus, broccoli, cauliflower, corn, endives, field peas, kohlrabi, parsley, potatoes, rutabagas, apples, blueberries, cherries, grapefruit, lemons, oranges, watermelon, grasses, all of them are there. So how are you doing? All you do is go out there. You can take a pair of pliers and squeeze it real good and get a drop of plant juice. So how do you implement all of this? Well, you take a composite soil sample. Composite soil sample, you're going to test each one of your areas of soil by color, by composition. Your soil will change. A given field may have more than one. It may only have one. So what do? You test each one and you go down. I mineralize a foot deep. That's pretty deep. But when you go on the web and you look at the roots of the various plants, you realize that many of the root zones are outside of 12 inches. So you double what most people cultivate, which is 6 inches, down to 12 inches, and you go around your field or your growing area, and you dig straight down with a clean shovel, and you take a stainless steel spoon and you pull it all the way up from the bottom of your 12 inches deep all the way up. You skip the duff, which is the vegetable matter at the top, and you put that, you sample 5 or 6 spots in that same soil, and you put them all in a Ziploc bag. Now you can use that paper bag, but they're going to dry the soil anyway, so it's no big problem. You send it to a good, reputable commercial soil lab. A&L Labs is a good one. A.L. Eastern is in Memphis, and the reason I use, well, I don't even send them to the lab. I take them to the co-op, because when I take them to the co-op, they cost me the same amount and they pay for the shipping. I don't have to pay for it. But by going to A&L Labs, I get that soil test reported to me in pounds per acre. Some of them report it in parts per million, and you have to convert it. And you perform your soil balancing. I take that soil report, you tell me how many square feet you want to mineralize, and I calculate it on a spreadsheet. And I can give you a quotation where the co-op will blend your minerals. You work them into the soil, you activate it with a 1/2 inch of water or rain, and you wait ideally 3 to 4 weeks before you plant. Don't have to, but you'll get better results by that. So, do you want body fuel, or do you want plain old washed out food that you buy in the store? That's the question we each need to answer, because, oh, by the way, it will taste different. It will probably be different than what I've been eating on a regular basis. I may not like some of it, but if it's better for me, that's probably what I need to be doing. We were growing, a number of us, in 6, 12, 30 by 100 foot greenhouses. We had the soil all set up. We had too much lettuce. It was coming up, it was passing us, and they said what to do. I said, pick a great big bowl, take it to the highest end restaurant, ask to see the chef or the owner. The owner's the last chef, and just show up. They said that was the easiest thing we ever did. He just reached and took some and started eating and said, where'd you get it? How much can you supply? He didn't ask about price. The kids will even tell you, I'd eat those greens. Those aren't bitter. I like that, Mom. If we had those, we'd eat them. So, make a decision. Decide what you're going to do. And my suggestion to you is choose premium body fuel.